Okay, so we'll continue with our discussions. Okay, so primarily, what are we seeing? What we have seen so far, and what we will see today is we'll have just quick summary, and then we can go ahead. We are discussing all this under graphics, right? Graphics Studio, and we are trying to learn how do we present our drawings in a technical way. Okay, so like I have said in the beginning, actually these are in architectural terms we call it as a language of architects. Okay, so for that matter, in our case also, we are trying to communicate our ideas through drawings. Okay, and in the process we have tried to see what are projections. Okay, what are projections? Projections are nothing but we have a three-dimensional object in hand, and what we try to do is we are trying to convert this three-dimensional object into 2D drawings, or vice versa. We have two-dimensional drawing, we try to convert that into 2D 3D drawings as well. Okay, so how do we do projection? There are different ways of creating projections. One is called isometric projection. The second one is called axonometric projection. Then we have something called oblique projection. Okay, perspective projection. And in addition to that, there is something called orthographic projection. Orthographic projection is nothing but the conversion of three-dimensional object into 2D drawings. Okay, 3D to 2D. Okay, so this is orthographic projection. Now, what is the major lesson that we should learn in the isometric drawing is, we have seen, okay, we are trying to construct this in a 30-degree base. Okay, that's isometric drawing. In axonometric drawing, the difference between, yes, somebody's mic is turned on, kindly check. The second one is axonometric projection. The difference is we are trying to draw this in a 45-degree angle. Okay, so in oblique projection, there is no specified angle in which this can be drawn. It can be drawn in any angle. Okay, isometric drawing, axonometric drawing. Okay, so these are the two primary things that we will be seeing. How do we construct this? You have already started with this, and we will see today how do we do this axonometric drawings. Similar way, in the same procedure that we followed for isometric drawings as well. In a way, that will be like a recap for those who have still not understood how do we construct isometric drawings. Okay, we'll also see orthographic drawings or orthographic projections. We will see how do we convert this into, how do we convert a 3D into 2D drawings. Okay, so in order to do this orthographic projection, we need a 3D first. Okay, so that's why either isometric or axonometric drawings are needed so that we can do orthographic projection. Okay, is it clear for everybody as of now?
Yes.
Okay, fine. So let's go ahead with what we have discussed so far, and then we will continue with a new topic. Yes, someone is saying something. Okay, fine. So last time what we have used one case study Okay, so we'll use the same case study and continue to discuss things. Okay, what is that? We have a building's roof plan. This is a roof plan. Okay, and we said the length of the building is 40 feet. Sorry, not 40 feet, 60 feet. From here to here it is 40 feet, and from here to here it is 20 feet. And on this side we have a parking area which is 15 feet, and here we have another space which is again 15 feet, and we have one room here which is 20 feet, and then we have the entire terrace which is 40 feet, and in the terrace we have one headroom which is 17 feet 6 inches away from this wall, and 12 feet 6 inches away from this particular wall. Okay, that's what we have drawn last time. And we have also drawn elevations. Okay, I see many of you are doing some errors in the drawing. Okay, when you draw plan, okay, kindly mention few things which is not there here as well. What we need is, we need to show, let's say if this is the street or the road from which the site can be accessed. Okay, mention the site. Okay, mention north. Okay, mention somewhere what is the scale in which the drawing is made. Okay, these are essential things. Okay, that's one thing. Second thing is, when you do the dimensions, okay, please kindly differentiate the difference between the line that you have used for the building and for the line you have used for the dimensions. 40, I'll just write just in case. Not centimeters, it will never be centimeters. 40 feet in this case. In your case, let's say if it is 5 meters, just write 5 meters. Okay, so this line thickness should be lighter than the object line that you have for the buildings. Kindly make sure that you draw it correctly. One thing. In the elevation, what I see is nobody is drawing the ground line. I've been repeatedly saying ground line should be there. That is the kind of a thickest line. Okay, we need to draw a thick guideline, ground line. Okay, on top of that you can have the elevations that you are trying to do. Fine, that's fair enough. Then additionally, for those who have already got the basic outlines like this, they are able to draw quickly. I said you can add the windows. Okay, just see what is the height and length and width. Okay, if there are openings, just add the openings, and also let's make that in the 3D as well. Okay, so last time I have not encouraged this because I wanted to see whether you are able to do the basics correctly. So those who are able to do it, you kindly start detailing it out, add openings, add, let's say for example, let's say this is not going to be a line, right? There will be something called a kind of a porch will be there. Okay, and there will be some column. You can add that. Okay, windows are not going to be just like a box. It's not going to be just one box. Okay, so it will have thickness. Okay, and it will also have shading element, right? Sunshades will be there. Add that. So for example, let's say here we are just trying to add 2 windows here. So window will not be visible here, but the sunshade elements will be visible, right? Make sure that you try to do that. And also here in this case, let's say this here I have a portico and it is standing on columns. Kindly show that column. It can be here or it can be flushed here, or maybe if there is no column here, you don't have to put, otherwise mention and show it. Okay, whatever openings that you have, put that. And let's say this is parapet, and parapet will also have some railing or wall, whatever. You try to add all the detailings so that it looks like as realistic as possible. Okay, all those things you will add now. You will start detailing it out one by one. Okay, so let's quickly wrap up the isometric view once again. What is the basis? What is the basis of generating isometric view? First we need this ground line, okay, and draw a 30-degree line. Okay, draw a 30-degree line both the side. Okay, once you do this, rest of the drawings will be fine. I see some of you have made mistakes in this basic thing is 12. Okay, I saw somebody had drawn like this. You have buildings, somebody shown a drawing like this. Okay, and probably what he has done is he has taken only this as 30-degree line and others are straight lines. Okay, we need both the sides. Okay, you should take 30-degree line on both the sides. Okay, don't make this kind of mistakes. Fine, quickly. So draw a ground line. Okay, add a 30-degree line, add another 30-degree line. Okay, and I add all the other parallel lines. I said in the beginning, you should make this as a guideline. You can have as big as possible, okay, within your drawing sheet, and then you can it can be guideline. Okay, first it can be guideline and then you can do detailing. Once you have done the base, do the all the detailing that you have in the plan, basic outlines. Okay, once you have done that, once base is ready, you can start constructing the 3D. Add height information, add this side, another side. Okay, I'm just trying to okay, further detailings, add height here, yeah, these are last time also we have seen this. These are as simple as possible that we can construct isometric drawing very quickly. Okay, now let's say I have also said all this. We have one face, second face, third face. On this, if you see from this side, we have 1, 2, 3 face. If you see from this side, on top we have 1, 2, 3. Okay, so this is basic things. Now let us say we have drawn only an outline. Okay, we have just drawn outline. Normally what you will see is you will have thickness for walls, right? So for example, let's say there will be a wall here. Parapet has got a thickness, isn't it? What is the thickness? You should add that. Okay, you can see how that basic 2D drawing is now, or maybe I'll draw it in black ink so that it looks more realistic. Okay, I'm just trying to add, let's say, parapet. I'm adding the parapet wall here. Thickness. So far I have not shown the thickness. Now I'm showing the thickness. Okay, so these are the roof now. You can see the depth that we have tried to generate. Depth as well. In all the openings that you have, let's say I'll just draw one big opening so that you can see how you can do. So some of you have already done this line. Okay, some of you have, I have seen in your drawings, you have done this. Okay, but this is not 3D, right? It's 2D. You have just drawn the 2D shape of the opening. You need to show the depth. Okay, draw the depth. Okay, you should get the depth correctly.
So what if the depth of the window is not visible?
It will be visible because it will see all the things are in 3D. So suppose if wall is normally done with 23 centimeters, 9 inches. Okay, so let's say if this is full wall, so what you will see is you will see 9-inch wall, 23 centimeters. If it is a window, it is not going to be 23 centimeters. Okay, or it is not going to be 9 inch, it is going to be 3 inch or 4 inch. So which is let's say 7 centimeters to 10 centimeters. Okay, so I'll show only depth of 7 centimeters to this. Okay, this is only opening. Again, you may have to add, maybe let's see if I can change the color. You have to add the frame, frame thickness, maybe if you have some vertical members, you can add that. Okay, so basically what are we doing? I'm just trying to draw it here in a big way. Let's say this is the depth. This is the depth we have drawn. What we are trying to do is we are trying to show this depth. If it is just a wall, show the depth, 9 inches or 23 centimeters of wall. If it is a window, what do we do? Let's say if this is depth of the window, what I am going to show is I am just trying to show a frame, window frame. Okay, so that this is a glass, this is going to be a glass. Okay, just try to add detailings in terms of 3D. You will start. You will be able to draw the details. Let's say I'm just trying to add a shading element here. Okay. Fine. So this is, let's say, some element. Okay, these are supposed to be in hidden line. You can erase it just to show 3D. Okay, whatever detailings that you have, you try to make it in a 3D format. Okay, fine. Let's quickly see the axonometric components as well. Okay, so what is axonometric view? It's the same as that of what we have seen in the isometric view, except for the fact that this is drawn in 45-degree line. Okay, now the angle is 45 degree. This is also 45 degree. All other things that we have discussed for isometric remains same. Okay, so we have a ground line, and then I have drawn a line. I have drawn one face which is 45 degree. I'm just drawing the other face. I'm just trying to add the height here, connect it, same, okay, for the same drawing that I have made. Now I'll do the other detailings. I'll add height, further height, connect it here, connect it this way, terrace. Okay, we had a headroom. I'm just trying to draw all that in a 45-degree line. Okay, so what is the angle here? This is going to be a 45-degree line. Okay, this is going to be a 45-degree line. This is going to be a 45-degree line. Whereas in the other case, this was 30 degree, this was 30 degree, and this was 30 degree. Okay, so that's the difference, major difference. Okay, similarly, if you see the face in axonometric drawing, you can see something like this. From the front, if you see, this is how it looks. From top, of course, you can see it. I have kept both the drawings in the same page. Now you can see, if you use an isometric drawing with 30-degree base, this is what the output that you will get. And if you use axonometric view, which is based on 45-degree base, this is what you will get. What is the difference between these two views that you see? What is your observation?
So there is more of the top with axonometric view.
Yes. Okay, you can see in axonometric view the roof is getting highlighted. Okay, whereas in isometric view all the sides 1, 2 and 3, all these sides are, if you draw it, okay, all the sides are getting almost equal importance, whereas here only the roof part is getting primary importance and other two sides are not getting as importance as the other drawing. Okay, so how does it imply? What does it imply? It implies that if we are showing something which is predominantly on roof, for example, in your case, when you draw the neighborhood 3D, we are not interested in looking at wall. Okay, we are least concerned with what is the kind of window there is been built. We are trying to look at what is the 3D, what is the three-dimensional view of a neighborhood. Okay, so in that case you can use axonometric view, okay, predominantly highlighting, okay, this is how the roof profile of the neighborhood looks like. Of course, you can do this isometric also, where we can also show windows and other openings as well. But you can also use axonometric just for highlighting the roof. So what you will do is, suppose if you are in a situation where you want to highlight some of the interventions that you do in the roof, I want to highlight this and show it to the client or to the examiners or to the let's say municipal administrators, whatever. your focus is on this. You want to show how much is the roof available and what we can use, how we can put this to use, all that. So if that is your intention, what you can do is you can adapt an axonometric view as your as a tool for generating 3D. Okay. In all other cases, you can restrict to isometric drawing where all the sides are getting equal importance. Okay, that's the major difference between isometric and axonometric view. Okay, I hope this is clear for everybody, and you should not have any doubts in this. Is it fine?
Yes, sir.
Okay, fine. So now the third component, that is called the orthographic projection. Okay, what is orthographic projection? I told you it's 3D to 2D drawings, converting three-dimensional object into 2D drawings. So in this case, what we will do is we need a 3D first, right? So in my suggestion is you should always use isometric 3D base. Okay, you should use an isometric 3D base for generating orthographic drawings. Why? Like I said, in isometric view, what will happen is we will give more equal importance to all the sides, all three sides. 1, 2, no, it's the same. 1, 2, and 3. Okay. So if you are trying to draw an orthographic projection, okay, so my suggestion is you should go for isometric 3D first. Okay, like we have done here. It's the same case that we have used for making isometric drawing. So I have made this. How do we extract 3D to 2D from here? So what we need to do is we need to project back all these edges into 2D drawings, like I have done here. From here, I'm just trying to project here. This line needs to be projected. This line needs to be. This edge needs to be projected, and this edge needs to be projected. Now I have got extended line. So what I do is now I will connect these. Okay. Now this is the face that is there in this 3D here. We are just trying to project that 3D, we are just trying to take that 2D component from here. Okay, so we have projected this baseline, top line, connect this, and this face is ready. Okay, so this is one that we are seeing here. Now we have more sides here. We can see how it can be done. You can see on top we have this headroom. Okay, I'm just now project this point here because that's how it will look like. Project this point, or put the height which is equal to the height of this. Put this height which is equal to height of this. Now project this point, and connect it. Okay, so that is also connected here. Now you see I have made this darker, I have made this lighter. Why?
Because that is in the front and the head part is in the back.
Yes. Okay, that's the thing. So the object which is in the front will be slightly darker, and the object which is in the rear will be slightly lighter. Okay, so you can see there are three different types of line. One is this is object line. This is also an object line, but this is slightly thin because it is away from the actual object line here. We also have this line, it is called hidden lines or hidden lines, right? Hidden lines, or in this case projectors or projection lines. Okay, so let's complete the drawing. We need to project this, project this, and now complete this face as well. Okay, so we have this face projected here, this face projected here, this face projected here, and that's how it looks. This is orthographic drawing of this particular face. Okay, so we have 3D here, and then we have tried to construct that 3D here. Okay, project and draw that 3D base here. Okay, so if we do for other sides as well, okay, I can do the same for this side. We can project all that edges and then construct a 3D. How is it looking from this side? I can draw for the rear side. What does it look? How does it look from this side? Okay, actually this should also be slightly thick line. Same. Okay, all 4 lines should be same. This is slightly away, so it will be light. On this side as well, okay, we have this part, we have this L-shaped part, we have this L-shaped part, and this part. Okay, so this is at orthographic projection. So what we need is we need a 3D base. Okay, we need to project all the edges. Okay, once the edges are done, you can just connect and complete the object lines. Yeah, that's it. I am done for the for this. And if you have any specific questions, you can ask me.